We're going to take a look at graphing quantitative variables. We're going to do dot plots, stem plots, and histograms today, and I'm going to show you how to use technology to do that fairly easily on your Chromebooks. If you're participating in the live lesson, you're going to use the actual data from our classmates. If you're watching this pre-recorded lesson, we're just going to deal with this example data set that's listed at the top of the page, but the idea is the same. So here, the first thing that we want to talk about is number of pairs of shoes, a categorical or quantitative variable. It would make sense to find the average number of pairs of shoes for the students in this data set, so that means that it's quantitative. And we're going to go ahead and enter the data and then use the data set to make these three graphs here. So I'm going to go ahead and jump over to Stapplet.com. We're looking at one quantitative variable. So that's what I clicked on at the very top. I just gave it a name of number of shoes, and then I typed in all of the data that I had listed at the top of my page. Then I click Begin Analysis, and it shows me this dot plot here. So I can go ahead and sketch that dot plot on my page, and I'm going to go ahead and do that quickly. You can do that as well. I'm not going to make it super accurate just because I don't want to sit here and have you guys wait while I make a very accurate graph. But I do want to make sure that I get things like the shape and center and spread relatively close to what they are, because we're going to describe those here in just a minute. Okay, so there's the dot plot. I then am asked to make a stem plot and a histogram, so I can just change this graph type. I can change it to a stem plot, and I'm going to go ahead and sketch that. And then I can do the same for histogram. So I can go ahead and change that to histogram. One thing that I can do here is if I wanted to split the stems, I can split them into two groups. We don't ever do 5 groups for our purposes. So again, that shows me the leaves of 0 through 4 on the first line and then 5 through 9 on the second line. And then I can change that to a histogram, and I can sketch that graph as well. And something that's helpful when I go to draw my graph is that I can put my mouse over this first bar and see that it goes from 0 to 5 and that there are 5 students in that category, and then 5 to 10 and there are 3 students in that category. And then here we've got 11 students in the 10 to 15 category, 1 student in the 15 to 20, and then 3 here, nobody in the 20 to 30, and then 1 in each of these final categories. So, oops, I can jump back here to my worksheet, and I've got my dot plot, my stem plot, and my histogram. We do want to, like I said, label. So for a dot plot, it's really just number of shoes or number of pairs of shoes. For a stem plot, that key takes care of it. For a histogram, my y-axis is frequency, or I can be a little more specific. In this case, it's the number of students, and then here the number of pairs of shoes. So now I can go ahead and describe using SOCS. So the shape of the distribution is slightly skewed to the right. We can kind of see that here. We've got a little bit longer of a stretch here, a little bit longer of a stretch here. Same thing going on in the dot plot. And again, like I had mentioned in the notes, you do want to kind of use those LY words when describing shape. So approximately or roughly, or in this case, slightly, because it's not extremely skewed. We could say extremely skewed if it was, in fact, extremely. For our outliers, we will learn how to check for those in the next section. For right now, it's just potential outliers, which are clearest in the dot plot and a little bit so in the histogram. Looks like we might have outliers at 31 and 37 pairs of shoes. And then for the center, we can just record the median for now. So in terms of my data set, I had 25 individual values that I typed into Stapplet. So I would just look right around kind of that 12th or 13th entry. So I can count that easily from the stem plot or from the dot plot. So right around 10. For the histogram, you would report the median as a range, and you would figure out where that 12th or 13th person was by taking a running total of the heights of the bars. So like I have 5 students here and another 3 students here. So I'm up to my 8th student by the time I get to this bar. Then I had 11 students here. So 8 plus those 11, this is going to be up to my 19th student. So I would say that my median is somewhere between 10 and 15 pairs of shoes, but I can't report it exactly from the histogram. It's just an approximate value. And then for my variability for right now, this is just the range. And remember, the range is actually one number. We don't just say that it's from 3 to 37. We take 37 minus 3, or the max minus the min, to get 34 pairs of shoes. And so for the last one, which of the types of the displays do you prefer? This is kind of a matter of personal preference. They all do give you something different. I kind of like the dot plot. And I'm going to say because it displays individual values. It's quick to make, even by hand. And I think it's fairly neat. It's a little neater than the stem plots, where sometimes these numbers tend to run together a little bit. Even though we should leave equal spacing, I think it's a little bit neater to look at a dot plot. I'll just say easy to read. But again, maybe you say that you prefer a stem plot. A stem plot still does preserve those individual values. We can find the exact median here. Or maybe you'll find that you like the histogram, because we're going to be able to make the histograms pretty quickly on the graphing calculator. So there are other benefits to some of these other graphs. It doesn't necessarily have to be a dot plot here. So here we're looking at comparing teachers to the students. And so here we have the results for the teacher colleagues, and we want to enter that data into Stapplet. So I'm going to pause here and go ahead and type that in. Okay, so I just switched from one quantitative variable single group to multiple groups, since now we have students and teachers. I just took that student data that we had previously, and then I added the teachers in there, and I typed the data from the worksheet. Then I hit begin analysis. And then for question 8 on the worksheet, it says to make dot plots, a side-by-side stem plot, and histograms, and copy one of the graphs. So I'm just going to go ahead and show you here the dot plots. We can see, just to compare the two groups, that obviously we have more students than we have teachers, but the student group is more variable. We've got a wider range here. And we can, this is what we'll talk about in the next group, compare those medians exactly, or we can compare the averages. On average, teachers are a little bit higher in terms of the number of shoes they have than the students. And then in terms of potential outliers, we definitely have those potential outliers we had mentioned for the students, maybe a couple potential outliers in the teacher group as well. I can change from dot plots to histograms, and I can see those two together. If you are trying to compare histograms, you want to make sure those scales are the same. So we see that here, because otherwise we can it'll be deceiving. The other thing that you may want to consider when you're comparing histograms, when the groups are different sizes, so we have more students than teachers, is change this to relative frequency. So then you can see the percent that fall into each category. And then it's a little bit easier to compare each group because you've got 12% here versus 28.6% here instead of comparing the counts when the original groups weren't the same size. So there are our histograms. And then here, let's go to our stem plots. So here you have a back-to-back stem plot. And this, I think, is your best graph for comparative purposes. So here you've got those common stems and then the leaves on either side. So it really allows you to compare the two groups with one shared axis, which we can't really do when we're looking at the histogram or when we're looking at the dot plot. So we're going to kind of consider this as we go through and answer question 9. So I'm going to go ahead and draw this in question 8 here real quick. You can draw any of the pairs of graphs, but I'm going to do the stem plots again just because I think they're the best for comparison purposes at this point. So I'll pause for a second while I draw this. Okay, so I've drawn my stem plots, and if I go over here to compare the distributions, I want to talk about it in context, and I want to make sure that I'm comparatively speaking. So I can say something like the distribution of number of pairs of shoes is slightly skewed right for both groups. So that's our shape. In terms of outliers, we said that we had potential outliers in the student group. We do maybe have potential outliers in the teacher group. It's hard to tell from the stem plot, but in the dot plot, it was a little bit more obvious. If I go back to Statlet and pull up the dot plots, these are a little bit further removed. So maybe both groups have potential high outliers. For the centers, we had said that the median value for students was 10. For teachers, it's going to be right around the 7th teacher because there are 14 of them, so I can just count my way up. And that median value is right around 12. So the median number of shoes is slightly higher for teachers than students. And then we can talk about range. So overall, the student group has a little bit more variability than the teacher group. We said the range for students was 34. And then the range for the teacher group is going to be 35 minus 6. So that would be 29. So we've compared shape, outlier, center, and spread. So we've got shape here, outlier, centers with the median, spread with the range, again, in a comparative way, in complete sentences and in context. So I talked about pairs of shoes, and I talked about teacher and student groups.